In this video we're going to look at multiplying and dividing surds, and it's using these rules. Now the first rule here we're already familiar with. We kind of used it the other way around, so we started off with say root 12 and split it into root 4, root 3 when we were simplifying surds. And if this works for multiplication, then we've also got it working here for division. So the square root of a divided by the square root of b is the same as the square root of just whatever a divided by b is. So what we're going to do before we start this is we're going to just have a look over here at some examples. And to start off with, what we're going to do is we're going to separate what is a kind of rational part of the problem, or a rational number, and then the part that's the kind of surd. So I'm going to highlight these in different colours to make it easier to kind of see what's going on. So my kind of rational numbers here, anything that's basically just a normal number, and then any of the surd parts I'll highlight in green. So the roots basically highlight in green. Now the rule we're kind of following here is when we're multiplying them, 2 times root 3, we can't just do 2 times 3 here and turn that into root 6, for instance. This is a rational number, this is a surd, so when I multiply them together, it's very much like multiplying 2 and x together. I can't really do it, I just kind of have to write them next to each other. So let's have a look. The answer to that one would simply be just 2 lots of root 3. Okay. Now in this one, I've got the rational numbers here, 5 and 2, and this root 3. Now the 5 can't multiply the root 3 because this is a rational number and this is a surd. So, but the 5 can multiply the 2 because they're both just normal numbers. So they can go together, 5 times 2, to give me 10, and the root 3 can't be multiplied by those two. In this one, these are both surds, so these can be multiplied together, and that's effectively using this rule up here. Root of a times root of b is the square root of whatever a times b is. So root 5 times root 3 is the square root of 5 times 3, so that's the square root of 15. In other words, because these are both surd parts, I can multiply them together to get this part here. On this one, have a think about what do you think this one here, which of these two do you think we can actually multiply by the 5 under that? So it's the 7 or the root 3. Now, the 7 is a rational number, so that's going to stay as 7. There is only one rational number there. But the root 5 can multiply the root 3 here and become root 15. And then lastly, we have a mixture here. I've got 2 root 3 times 5 root 7. And again, the rational parts of those, the 2 and the 5, they can multiply together. So that can give us 10. And then the surd parts, they can also multiply together. So root 3 times root 7 would give me root 21. And hopefully that gives you an idea of how we go about multiplying surds together. Now we'll have a look at example A now and see if that helps us. So in algebra, normally when we're multiplying, we follow the kind of rule, multiply the signs, is the answer positive or negative? We then look at the number part and then we multiply the letters after that. When we're dealing with surds like this, then it's the same kind of idea. We look at the signs, positives or negatives. We then multiply the rational numbers, in this case that's the 3 and the 5, and then we multiply the surd parts, which is the root 2 and the root 7. So let's go through this stage by stage. So first of all, signs. It's positive times positive, so the answer is positive, so we're not going to write anything there for that. The rational number part now, 3 times the 5, that's going to be 15. And then the surd part, root 2 times root 7, using this rule, root 2 times root 7 is the square root of 2 times 7, so that's going to be root 14. And that's it, fully simplified. Now, similar with this one, let's start off with the sign. So that's positive 3 root 2 times negative 6 root 6. Now positive times negative is going to give me a negative. And then the rational number part, so that's the 3 times the 6 there, that's going to give me 18. And then I've got the surd part, root 2 times root 6. Now 2 6s are 12, so root 2 times root 6 is root 12. Now, we can actually go a little bit further with this, and it's one of the things you always have to actually check, because in this case, this root 12 can actually be simplified a bit further. So if we look at this, we have this minus 18, but root 12 can be simplified into root 4 times root 3. So root 4, root 3, and that then becomes negative 18 times 2 root 3, which becomes negative 36 root 3. So that's something to bear in mind when you're dealing with surds, is after you've multiplied surds or divided surds, then sometimes the surd you've kind of got here can actually be simplified. So it's a good idea just to always check, can that be simplified each time. We'll now have a quick look at these three examples here. Now remember, root a divided by root b is the same as the square root of a divided by b. Now, what you'd always check before kind of going on and just using that rule straight away is, can 24 actually be divided by 2? Because if not, it might be a better idea just to try and look to simplify the top part. But here, 24, we definitely can divide that by 2. So the square root of 24 divided by the square root of 2 is basically the square root of 24 divided by 2. Now what you can do is, 24 divided by 2 is 12, so you can just write that as root 12. Now I'm quite happy if you went from that stage to that stage, that's okay. I've just put this in here for this video. When you get to this stage here though, always check that the surd you're kind of left over with can't be simplified further. So basically this root 12, we know there's a square number that goes into root 12. And that number is 4. It's 4 times 3 makes 12. So that's root 4, root 3, and the square root of 4 is 2. So 2 root 3. And again, let's have a look at this. This is the reverse. Now what I could do with this is I could see if I can actually do the 4 divided by 9, but in this case I can't. So it might make sense for me to use that rule in reverse. So the square root of a over b is equal to the square root of a over the square root of b. So basically I'm going to split this into two separate square roots. So I'm going to make that the root of 4 over the root of 9. Now if you look at both these, can we simplify them? And one of the things you'll get used to is actually just spotting when you see a square number here and here. So we're not going to need to check what the highest square factor of 4 is, because 4 is itself a square number. Square root of 4 is just 2, so that becomes 2 on the top. And again, we don't need a square factor of 9. 9 is a square number already, so the square root of 9 just becomes 3. So that simplifies down to 2/3. Because we're multiplying and dividing surds, obviously it makes sense that we use some of the things we've done before. So multiplying out brackets is something we've done before with algebra. So multiplying out brackets with surds is again something we could do here. Bear in mind what we looked at in the last page. When we have this 3 root 6 multiplying this root 2, you've got to think about which part of this here is going to multiply with the root 2. So the 3, it doesn't have a rational number in front of the root here, so that 3 is going to remain as a 3 when I multiply that first part, so it's 3. But the root 6 can interact with the root 2. Root 6 times root 2 is root 12. Now, the next part, which I'm going to draw the second multiplication line in here. Again, I've got to think about what part will interact with what. I've got a 3 here, which is my rational number part, and there's a 5 in front of this. That means that 3 and that 5, they can interact. 3 5s give me 15, so it's positive 15. And then here I've got root 6 and another root 6 here. Now, root 6 times root 6 will become root 36. Now again, when you get to this stage, it's a good idea just to check, can your surd parts be simplified further? So, can we simplify root 12 further? Well, we did that earlier on here. We know root 12 simplifies down this way, so let's quickly fill that in. So that's 3 times root 4 root 3, which is equal to 3 times 2 root 3, root 4 turns into that 2 there. And then 3 2s are 6, so that's 6 root 3s. Now, I've kind of gone straight down from this and simplified it all the way down. This one here, we still need to check, can that be simplified? So your first instinct when you're dealing with surds is probably think about what's the highest square factor that goes into 36. But that's why, again, right now that list is really useful and using it, because actually when you're out of the list you realise 36 itself is actually a square number. So we don't need to kind of simplify it in that normal way for simplifying surds. Root 36 is just 6. So this becomes 15 times 6. So plus 15 times 6. Now 15 6s are 90. And we'll just fill that in on the lines below and see if we can simplify that any further. And the 6 root 3 can't go together with the 90 there, so that is now fully simplified.